Right, we'll carry on with question 7 on this worksheet. Scientific balloons are tested in a lab before they're used. In the first step, test the pressure of the air inside the balloon. I can't read. The test pressure is 120 kilopascals. The balloon is sealed and has a volume of 92 meter cubed. The pressure of the air inside the balloon is reduced to 64 kilopascals by reducing the external air pressure. Right. For this question, you've got to know P1, volume 1, is equal to pressure 2, volume 2. It's basically this, look. So there's a balloon. It's got a volume V1 and a pressure inside it P1. If I increase the volume, so V2 is bigger, the pressure inside, so I had, just say for example, 5 molecules. I've got still 5 molecules, but what's going to happen is the volume is going to be bigger, so the pressure is going to be lower. The volume is going to be greater. The pressure is going to be high inside here, and the volume is going to be smaller. So we're saying the pressure times the volume in this equals the pressure times the volume in that. So we've got to learn this formula. So look, there's 3 formulae we need to be familiar with. Let's write them out. So we said pressure in a liquid is high times density, rho, times gravity, and then we know pressure is also force over area, and the third one is pressure 1 volume times volume 1 is equal to pressure 2 times volume 2. Just go ahead and internalize these. Okay, you'll be given it, but if you know it off the top of your head, it's easier to access it then. So what they're saying is, look, they've given us that and that. So we're saying 120, 1, 2, 3 kilopascals times 92 must equal, is reduced to, right, not by, 64, 1, 2, 3 times V2. How do we do this? Right, we've got that, so we can now say V2 equals 120. I'm assuming it's going to say meter cubed, yeah. So 120,000. We could have just used 120, right? Divided by 64,000. And your answer comes out as 170 meters cubed. Right, that's that done. Give an assumption made that is made in this calculation. Right, okay. Air temperature is constant. Right, that's the one that I know. And the other one that they've said is the same amount, same volume, not same mass of air, same amount of air or mass of air. So if you're the same mass of air, you'll have the same you'll apply this formula. Right, let's just leave it at that. Right, okay. Let's move on. Right. The pressure of the air in the balloon is returned back to 120 K. The temperature of the air inside the balloon is 290 Kelvin. Right, let's just have a quick look at the Kelvin scale. It'll be useful. Right, it's going to be useful, this actually. So if you want the Kelvin scale, you take the Celsius scale and you add 237. So if I wanted the freezing point or the freezing temperature of water, I know it's 0 degrees C. If it's 0 degrees C and I want it in Kelvin, I'll do K equals 0 plus 237. So the freezing point of water is 237 Kelvin. Right, that's another good one to remember. Right, okay, we need to add that here. So we know Kelvin equals degrees C plus 273. There you go. Right, okay. So we're testing the balloon again. The temperature inside the balloon is 290. So if we did 290, take away 273, what's that? That's, I can't remember this, 17 degrees. Yeah, 70 degrees Celsius. Right. Changing the temperature, keeping the volume constant. Explain why the pressure of the air inside the balloon decreases when the temperature decreases. Right, it's 3 marks. It's to do with the kinetic energy. So what I'm going to do is I'm going to add that here. So the kinetic energy of the particles decreases. So there's fewer collisions with is that how you spell with? No. With, I've done it again. What's wrong with me? With the balloon wall. Right. And because you've got a lower speed, there's two things. There's less collisions, and each collision is with a lower force, not as hard. And since pressure is force divided by area, the pressure decreases. So look, this here is a similar answer to one of the previous questions. So what you need to do is talk about, look at this graph here. This is how I taught the little ones at home. The kinetic energy decreases. So that means that there's fewer collisions and with lower force. Because since F equals mv squared, remember that F, the force is half times mv squared, half mv squared. So if the velocity goes down, the force will go down. And since pressure is force over area, the pressure will decrease. That's it, done. So calculate the temperature when the pressure is in the balloon is that. So what they're saying is when, where are we? Up there, right. 120 over 290, 120 kilopascals over 290 is the same as, where are we? See, I've got to be careful with that K because that's going to confuse, that's going to make it look like Kelvin. So let's do 120, 1, 2, 3 pascals over 290 Kelvin is equal to 64,000 over temperature 2. Right, that's that first thing. So it's P1 over T1 is equal to P2 over V T2. Goodness gracious me, that's another formula you've got to learn. Do my head in. Don't know how you lot are going to survive. Good luck. I'm off. Getting late anyway. मैं छुट्टी करता हूँ. Right, okay, so that's your first step. It's a 3 marker. Let's rearrange that. Let's write T2 64,000 times 290 all over 120,000. Right, look, if you're struggling with this, I won't worry about this. At least try to write this. So if you can use this, because you're going to be given a formula sheet in 2024, so I don't know if you'll be given it in 2025, but take advantage of it. And then T2 is 150 Kelvin. See, the problem with K is it's confusing in the sense that it can cause you to think, ooh, kilo, but it's not. Right, okay, let's try to do this one. That was a long question. Right, photograph shows mechanic pumping air into car tire. Right, we just go over the formula. So we know pressure equals height times density, which is rho, times gravity. We also know pressure is force over area. We also know pressure 1 times volume 1 equals pressure 2 times volume 2. We've also learned that P1 over T1, and I had this in my head from years back. Pressure 1 divided by temperature 1 is equal to pressure 2 divided by temperature 2. Constant volume and this is constant temperature. Oh dear. And you've got also remember kinetic energy equals this, you know this anyway, half mv squared from other stuff. Right, okay, so these are the 4. If you can, nope, you're on to a winner. Right, okay, before being pumped, some air has a volume of that at a pressure of that. The pressure of the tire, the pressure of this inside, the pressure of this air inside the tire is 270 kilopascals. Calculate the volume. Calculate the volume. So we've got volume and we've got pressure. So that's this formula here. So we're saying the initial pressure and volume is equal to the final pressure and the final volume. There's no change in temperature. Does not change, okay? and they want it in standard form, so there's a lot going on here, so we've got to be careful. So the initial volume was 0, right, okay, let's write the 100 kilopascals. 100, right, I'm going to leave it as kilopascals. 100 times 0.0043 is equal to 270 times volume. Right, so we rearrange this. In physics, they like you to rearrange this before working everything out. It's 100 times 0.0043 divided by 270. So the volume 2 equals 0.0016 meter cubed. But they want it in standard form, so this is where your maths kicks in. There you go, meter cubed. Right. So again, please try to remember these therapy, trying to teach kids. Yeah, right, there you go. Right, a car is fitted with a tire pressure monitoring system. A warning light will show in the car if the air pressure in the tire falls below 250. Using the idea of particles, explain why the air pressure inside the tire is lower on a cold day than a warm day. So look, do you know this question here? It's almost a carbon copy of that. Right. Let's see if we can remember. There's 3 marks. So when in winter the temperature is lower, so the particles or the molecules or the particles or the atoms have lower kinetic energy because they've got a lower kinetic energy. Remember we said kinetic energy is related to the velocity, isn't it? Half mv squared. This is v, by the way, before you start complaining. I like to put a little tail on because it differentiates it from a u. So if I did uv, I know uv. Anyway, I'm waffling. Let's stop waffling. Delete that and crack on with it. Right, have a lower kinetic energy, so move slower, move more slowly. So the particles collide with the tire walls less often and with less force, and since pressure is force divided by area, the pressure decreases. So it was a carbon copy of that other question. So look, this is what I'm trying to say to you. If you can learn these few steps, the key thing is there's a lower temperature, so the particles have a lower, oh my god, am I doing that? Yes, I am. Let's not do that because we're professionals. Not professional what, but so the temperature is lower, so the lower kinetic energy, so they move more slowly. So the particles collide with the walls less often and with less force, and since pressure is force over area, the pressure decreases. Done. Now you are officially a pressure expert. My head's killing. Right, okay, let's keep going. The air pressure is 270 The air temperature is 20. When the air temperature is 20, what is the pressure? So they're looking at this formula. Okay, P1V1 equals P2V2. Right, so let's just simply do that. There's no big deal. P1V1 equals P2V2. P1 is 270. I'm going to leave it as silly person. Why did I do that? My apologies. Just seeing if you're awake. Honestly, I knew what I was doing. Right. It's pressure and temperature. Pressure and temperature. So the pressure is 270 divided by 20 equals pressure, which we don't know. So let me write that out again. Pressure, but we know the temperature is 2. Let me get rid of that. It just looks not nice. Right, okay, so we want to work out this unknown pressure. So we do 270 times 2 divided by 20, which equals pressure 2. Pressure 2 20 degrees. We should get 200. Have I done that right? Pressure 1 over temperature 1. 270 over 20, 90, 275. Oh, does it have to be in Kelvin? No, it doesn't. I don't see why. Right, just bear with me. Let me check that on the calculator. I am a genius. I just discovered something. Right, so this I didn't know, but now I do know. Right, okay. Lesson number 1. The temperature has to be in Kelvin. So pressure 1 was 270 divided by 20, but we need to add 273 equals pressure 2 over 2 degrees plus 273. Right, so therefore pressure 2 equals 270 plus 270 plus times all over 293. So basically I've added these two together and taken it up, and the answer is 253 kilopascals, because we were dealing with kilopascals here. We didn't bother adding 270,000 pascals. Right, okay, let me, before finishing this video, let me just go over all this stuff here. Right, bear with me, let me get a new page. Right, let's get this right. Pressure is height times density times gravitational field strength. Yeah, that's for when you've got a liquid. Pressure also equals force over area. Pressure is measured in pascals or newtons per whatever, but normally meters squared. Right, we know pressure 1 times volume 1 equals pressure 2 times volume 2. We know, okay. Pressure 1 over temperature 1 equals pressure 2 over temperature 2. Right, with this we have to convert to Kelvin. Right, let's have a look. Convert this to Kelvin. How do we convert to Kelvin? Kelvin equals degrees Celsius plus 273. Right, you need to know all this. Whew. Right, we'll call it quits there.